So today we'll be starting a new topic, that is Git or GitHub we can say, right? So Git and the GitHub. So this is a very new topic, though it's a very small topic, like it will around 6 to 8 hours, but there are a lot of things are there to learn in the Git because Git is one of the versioning tool, right? It is it's one of the versioning tool, what we are using these days. Git basically, and Git plays a very vital role in many of the industry because most of the industries are using Git as their source code versioning. Why? Because again, Git is an open source and it's an open source, so that you need not to pay any money for buying the Git tool. So you have to plainly install that Git software or the Git package in your machines, and you can start working on that. And the second advantage of the Git is actually that the first advantage is that it's an open source. Why most of the industries are using Git? So Git is an open source actually. So it is freely available. You need not to pay any, like any licensing cost for that. No licensing cost. It's fine. It's free, right? So you can install in any machine. And Git, the second is Git is a platform independent. Independent. It means that you can install Git in Linux, Windows, Mac, anywhere you can install it actually. And the furthermost is that actually Git is very simple to use actually. The fourth important point is that Git supports a lot of complex projects actually. So you could see that in many industries there are a lot of complex projects will be running on, and you need to maintain a lot of versioning for those codes and everything. You need to maintain a different like different versions or different branches and all. You need to maintain it. So so Git plays a very vital role, and it also from the simple project to a very highly complex project it supports. And you know very well that the first most project which Git was supported was the Linux itself. The Linux kernel itself is a huge project actually. So what it happened, right? The whole Linux kernel itself was actually maintained in the Git source code actually, Git versioning tool. So if such a big complex project has been used or it has been maintained with the help of the Git versioning tool, think about that. If you see about any other complex project, even like including like a SAP projects where it has a lot of models, lot of still SAP also uses in some places they use the Git as a tool actually. So Git is a very important tool, and we would be using a lot in the industry, and almost most of the industries, whatever the tool which they are using right currently, maybe it might be a proprietary tool or it might be a paid tool, right? They are trying to move into the Git actually now. So Git is a open source, and as I said, it's a freely available. So that's the reason. Now, now in our like what we will be trying to learn in this Git sessions actually, basically we'll be learning about the usage of the Git from the client point of view, from the client side point of view. It means that suppose you are a user, you want to use a Git as a source code versioning. It means that you need to enable, your all your code into the Git versioning. What are the commands you will be using so that you will be start working on Git? So that's what it is from the client side, how you will be using the Git tool, and also to some extent we will be also be understanding about how the Git works in the server side actually. Like for example, the server side means it is something like a GitHub server side, how exactly it works. That also, it's very important us to understand, right? So how in the server side, how it is maintained, how versions are maintained, right? What are the user management which are involved in the client side, sorry, in the server side. So in the server side, right, in the Git server side, that is basically GitHub, right? Basically, so we'll get into understanding about what is GitHub later. But this is a server side where you need to understand, like what are the how the user management can be done in the Git server side, right? What are the permissions provided, right? And how you can actually enable using any project under the Git using this GitHub or Git servers. So all those stuffs we will be no learning. These are the kind of a services which are provided by the Git server. So we have to learn even this also. So what I'm trying to tell that from the client side also you need to learn how Git works, as well as you should have some ample knowledge in the server end also how the Git works even in the server side, so that no, you will get an overall understanding about how exactly Git performs in the industry, how they use the Git tool, right? So that's what it is, sir. So it will be it will be a small session, like between 6 to 8 hours of sessions we would be covering, okay, in the Git, and we will see how we goes, how we can cover up all these sessions in the upcoming days. Okay. Now, so let us start to understand what is a Git. But before we start learning about the Git, actually, you need to understand from the high level, like how the source code is managed. See, like every industry, that every industry has their every industry, that every software industry, very well that they have the developers, right? They have the developers, or the developer, the people who develop the applications, right? They develop the applications, correct? So they might use any language like Java, C, C++, or SAP, or any kind of a .NET language, any language they can use to develop an application, correct? Now, now the question comes that okay, they write the code, it's fine, but how the source code is managed? That is what the challenging part. How source code is managed. Now, if you see in a very olden days, a very long back, like 15, 20 years back, like how the source code is managed or maintained. So let us see a scenario how they maintain it actually. So, like for example, okay, let us have a company, okay, some XYZ company. Okay, we'll take some XYZ company. They have some few developers. Like let us take some two developers. They're having two developers actually as of now. They're having two developers. Okay, so now, and they're working on some project. So let us say that they're working on some e-commerce project. Okay, e-commerce project. So yes, start. Okay, so assume that okay, he is one developer, so you can take anybody, and you can take anybody. You can take this image. Okay, okay. So we'll take his own developer. He's a developer actually, and we can tell his name is Ram actually, and he is a developer one. Okay, we'll have one more developer actually. Anybody you can take even this person, or we'll take this person. So he is a developer too, and sorry, yeah, he's a developer too, and he's his name is something like Robert. He's a developer too. Now you know very well that they both are working on the same project, like e-commerce project. That means that they would be working on the same source code, correct? Guys, they'll be working on the same source code. Now, what happened that Ram will try to do, or he will try to write some codes or some codes lines in his file or in some of his files. He will write some source codes, right? Or he will try to code some certain things. Now, Ram has coded it. Now, Robert is also trying to code something into a file. So, Ram has did it, and even the Robert also has to do it. It means that he will also start writing a code in some files. So is it required, right? What is the requirement is that actually whatever Ram has coded, don't you think that the Robert needs to understand or needs to see those codes, right? He need to basically understand also, right? He has to understand what has Ram has written, or what kind of a feature, for what kind of feature he has written the code, that Robert has to understand. Similarly, whatever has coded it, even Ram should also have an information on that, what he has basically coded. Correct. So Ram also should know what Robert has coded, right? So it means that basically the both of them have to share their codes each other, either at the end of the day or within some few days. They have to share this code actually. Now, how they used to share this code earlier? That means that I'm talking about very long back, like when people were working on some application like 20 years back, how they used to share this code actually. Basically, they had some kind of a shared folder or shared drive they had actually, basically, right? So in that shared drive, they used to share the code. It means that Ram used to upload his code under some shared drive at the end of the day. And Robert is to download that from the shared drive and he is to check and is to look what are the changes which have been made by the RAM. Similarly, Robert will upload his code under the shared drive. So that was a common shared folder where the developers were submitting their code, right? So what is it? So basically, they were trying to have some kind of a shared folder image. If you take any image like anything like assume that this is a good diagram. Okay, this is a good diagram. Okay, so this is a kind of a folder they used to have, shared folder where Ram is to upload all the codes at the end of the day to the shared drive, and Robert is to download it. And again, Robert, whatever Robert is to do, he is to upload into the shared drive, into the same common shared drive, right? So this is basically a very simple approach, right? How the people were able to, upload their codes, where so that the other user can or the other developer can use or see those codes actually, so that he will be able to understand where Ram is working, and similarly Ram can understand where Robert is working, like that. This is the case of the scenario where there are only two developers who are working on the same project, one project actually. Obviously, both of them will try to even write into the same file also. So, if suppose in this project they have written some 100 files, it doesn't mean that Ram will be working on some set of file and Robert will be working on the other set of file. Not like that. It is possible that they can actually write into the same file. Even to some extent, they might be writing or they might be editing into the same line of code also. So those chances are there, those possibilities are there that they will try to write into the same file under the same line of code also. So that is possible, right? So now, so this as I said, this was basically a very simple approach, right? But here, what was a major problem which you can see over here? The major problem that two people, means both Ram and Robert, they cannot work onto the same file at the same point of time. So that was a problem actually. So basically, this was a problem statement, right? So it means that in case of a shared folder approach, they cannot edit or they cannot work onto the same file at the same point of time. So this was a major problem, right? So shared folder concept is not good. I mean, it is not good that you use a shared folder for submitting your codes or maintaining your code in the shared folder, right? So that is not a good approach. So this was a very bad design, or this was a very bad use of submitting your code actually. So this was a very old when people used to do like this actually. Some people used to even send their codes at the end of the day to the email also. So today I have written some codes actually, some files I have edited. At the end of the day, what I will do, who are all the developers are there in the organization, right? Who are belong to that particular project, they have to send an email to everyone so that everyone can download the files, look into the code and understand, okay, this particular developer has written it. Even that is also a very bad, way of doing it. But during that time, there was no versioning tool which was used to submit their code actually, right? So okay, let us maintain the notes now. So now, so you know that multiple developers work on the same source code for the project, right? So to make this possibility, uh, to make this as a possibility, or you can say the reality, you can say, we use, means in this scenario I'm saying, we use a shared folder, right? A shared folder was used, right, guys? A shared folder was used. So as you know, this shared folder, right? This is a simple approach, earlier, long back. This was a very simple approach which was used across the project, across the organization to share their codes. Actually, it was a simple approach. But what was the problem? We saw now. We understood now that two people cannot work on the same file at the same time. Correct, guys? Because there will be a conflict actually if they try to work on it, right? So now to make source code management, to make source code management effective, users or developers, you can say, users or developers should be able to go back to history to find out the changes. So what it means? See, for example, now assume that actually that okay, I'll remove this or else. Now assume that RAM has written some code in a file actually. Suppose RAM has did the some code and he has basically what he has did, he has written the codes actually. He has written some code yesterday and today he is trying to write a code. Now, what Ram understood that okay, whatever I have written the code yesterday, it is a wrong. It is that code is not correct. So I need to remove all those codes which I have written. Suppose like Ram will open some notepad. I'm just showing an example. He will he'll open a file like this. Sorry, I think I have to open a notepad. Okay. So what he will do, he will try to write the code like this. Yesterday's code change. And today he has written. So this was the line of code which he has written yesterday. And today he has written the today's changes he has written. Now assume that Ram felt that whatever I have written the code, sir, yesterday it was wrong actually. So because of yesterday's code, no, it has messed up certain things today. So what Ram will do, Ram will go basically and he will try to remove these lines of code, right? He will remove the lines of code what is coded yesterday. But do you think that it is so simple to do like that way? That means that here I'm just showing you just only one line. It doesn't mean that RAM has did changes in only one line. He might have edited a lot of files actually, more than two, three, four, or even 100 files he has edited, and he has edited at the different location within the file, right? So RAM has to remember all the files are where and all he has did the changes, and he has to revert back also because he has to remove all those codes whatever he has did it. Do you think that it is a simple approach or it's a simple process where RAM can go and rechange all the things whatever he coded yesterday? It's difficult, right? It is kind of a, it's not like a impossible. It takes a lot of time and it's a manual way of doing it because you should remember what are the code changes on which are all the files you did, right? That RAM has to remember completely or he has to note it down. So RAM has to do additional work also. Practically seeing, like, it is impossible actually. It means that if he has coded some 50 files, different lines, right, going and rechanging or undoing everywhere, no, it is practically impossible. He might miss to change into some few files also. That is possible. So what is happening is that it means that whatever the code you are writing, no sir, you don't have any kind of a versioning on that. It means that suppose you did a today yesterday's changes, you did yesterday, you added a code, right? So there has to be some kind of a versioning. Okay, this is the version for yesterday changes. So yesterday changes. Oh, this is some kind of a version for this. Okay. Today, what are the changes you did, right? There should be one more kind of a versioning for that. So that what happened, right? If there is a versioning concept is there, then RAM will know that okay, I don't want to do that. I don't want yesterday's changes. You can go to this yesterday's code or yesterday's version, and where and all the files which is having this versioning, right? He can remove that particular version so that all the files which have been changed, right? That everything at one shot without any difficulties, he can revert back or he can remove back that. So here what is happening that versioning plays a very major role whenever you are submitting the code. It means that yesterday you have written the code and you are submitting it or you are you can say the committing or submitting. It means that a particular version will be given or something like some ID or some number will be provided for that. What is this? We will see later. What is this versioning and all? We will see later. Don't worry now. So Whenever any code changes is done and committed or uploaded by the RAM, okay, into some software where it maintains the versioning, some version will be provided like that, right? So now what happened, right? We went across with the share folder, but we know that share folder is not a good approach because you, as we saw that two people cannot work on the same file at the same point of time, right? So that was a major disadvantage. Okay, later after some point of time, okay, what happened, right? There was some software. I don't know what that software is. Okay, let us see some software. With the help of the software, what happened, right? You are able to maintain some kind of a versioning actually. That means that for each and every code commit which is done by the developers, code commit done by the developers, okay, some kind of a versioning is to get enabled. It means that if this is a software which is installed in something and you're trying to upload this code, which is code developed by the RAM, he's uploading, some kind of a versioning is provided. You can say versioning something like a history information is provided, something history information. It will tell you, okay, to yesterday, what are the lines of code which you have added into the file, what time you have added. It is something like history, right? So versioning is not, but it's a history information which is maintained for each and every code changes which is done by the developer. So some software we don't know. We'll see later on what is that software. It has some kind of versioning, right? So earlier what happened? There was no versioning concept actually. Now what happened? The versioning concept has come into the picture. Okay, so that is what I have mentioning over here in the notes actually. So to make a source code management effective, the user or the developer should be able to go back to the history to find out the changes. It means that whatever RAM has did the changes earlier, right? He should able to go back and see changes also. Okay, yesterday I did this changes, today I did this changes, right? One second, guys. Right, sorry, guys. So 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 it means that whatever the changes which is done by the particular developer, here in this case Ram, right, he should go and see his changes whatever he has did. It means that he will know what are the changes which I did 1 week back, what are the changes which I did yesterday or today. He can actually he can analyze and he can see it. Why? Because, right, there is a versioning is being provided for each and every code submit, right? So that's what it says, that's what this says that actually. Okay. Now, after that, to make the source code management effective, the user or the developer should be able to go back to history to find out the changes. Fine, that is correct. Now, what else? So, we need some kind of a versioning, or we can say as a revision. We can say that is a nice word, revision, for every code changes made by the developer. Guys, do you agree with me? So, if a developer in a file, if he's just adding only one line, so there has to be a versioning or revisioning for each and every code changes whatever is done by the developers, right? So that to maintain the history of all changes, correct, guys? History of all the changes. So how we can define? So these are all the things, sir. We need it actually, right? So it means that whenever you want to maintain your source codes, right? Whenever you want to maintain your source code management, that source code management tool or the software, it should support all these things. So it means that it should support for the versioning. Okay, fine. Somebody might say you, somebody might call and say that, okay, Git is there, right? Git is a versioning software. It enables the versioning, or it means it supports the versioning. Fine, that's all fine, correct. So that's how Git is supporting all these features. But what I'm saying that, whenever you are working on any source code management tool or the software, right? Those software should support all these features. It should make sure that actually the user at any point of time he can go and he can check the history of, or he can find out all the changes he's done previously, right? As well as that's what you need to maintain the history of all the changes, plus you need to even need a versioning for every changes made by the developer at any point of time. So this is what it is required. So how we define a versioning tool, or what is the definition? If we say that versioning control system is not what, it's a control software, or it's a control server, control system we say. also called as or also known as, you can say, known as source code management or source control, is known as also source control, is a software that manage changes of or manage changes to the software code by maintaining versions for each changes. That's what. So as and when he does the code changes, so it has to manage the version, that one. Okay. Then what is other things? What are the other things which it allows, or the source code management software? Okay, it has to allow multiple users, right, guys? Multiple users to use the source code parallelly. It means that now you could see that here at any given point of time, here in this case, Ram and Robert, they cannot work on the same file at the same point of time. That was a major disadvantage. But as we keep moving forward, as new softwares were coming, the versioning software were coming, they were allowing the multiple users also. It means that even the multiple users can also edit, or they can also work on the same files at the same point of time. So it was possible actually. So that's what I say, that multiple users also allows multiple users to use the source code parallelly and submit the changes actually, and submit their changes actually. Guys, I'm getting a call. One second. Sorry, guys, I was got a call. Okay, so what I was saying, that actually, so it allows the multiple users to use the source code parallelly. It means that parallelly you can do the changes in the same file. Earlier, it was not supported, right? As I said earlier, it was not supported, right? And what are the other things? What the versioning tool support? It should even support for the backup and restoration, right? So it means that what are all the source codes you have, right? What are the source codes you are submitting it? There has to be some kind of a way where all those data has to be backed up in some other server also, right? And restoration option in case of a server failure. If suppose if this server fails, there has to be a mechanism where you can restore back all your code what you have developed, right? Otherwise, if the server goes down, if the server gets crashed, right, you are losing the all the data, right? So whatever Ram and Robert have developed, right, everything will go washed away. It will go in vain, right? So that should not happen. So your source code management tool or the software should also help or enable the backup and restoration option. It should provide backup and restoration option should be provided in case of server failures. Guys, do you agree with me these points? Guys, do you agree with me what I'm saying? Yes or no?
Yes, Rajesh.
Yeah, yes, sir. Yes, sir.
Yeah. So that's how. Okay. Now, so that's how the versioning came into the picture, where you have to provide some kind of versioning for each and every changes, right? So now, post this. Sorry, some of you can mute yourself. Can you? Okay. Guys, some of you mute yourself, please. Who is it?
Somebody guessed, sir, I think.
Yeah, please mute yourself, guys. But who is this man who has enabled it actually?
Yeah, sir. Even video also you will get.
Yeah, know how he is able to add it. Guys, please.
You can mute, sir.
So
I
please,
muted him,
guys.
sir.
No, still is coming. Okay. 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 Now, what is our next thing? What we have to understand? We have to understand the generation of version control. It's very important, guys. We have to understand what is the generation of version control systems. Right. Now, you could see that there was something like a first generation actually. First generation. What was the first generation basically? Okay, I'm talking about like when the when the people were working very long time, right? When the developers were working, right? How they were managing all this source code versioning tool, like how they're managing their codes actually. So in the first generation, what happened, right? If I talk about something like a networking, so networking was not there at the time. So you can say as a networking as a none actually. Okay, it means that there was no networking. It means that when the developers are developing the code, they were developing the code, and their code is to only reside in their own machine itself. It was not at all being shared in some common location or in common server where the entire repositories of source code were maintained. So it means that whoever are developers or the user, right, they were developing the code in their own machine itself, and the code will be resided in their system itself. Actually, that was the stuff actually which used to happen earlier actually, and in the first generation, what are the operations we're able to do? It means that one file was edited or was edited at a time actually. So you cannot do multiple file edits was not possible in case of a first generation. Okay. What are the concurrencies? Concurrence means or the parallelly. Do you think that parallelly can you work on multiple files? No. What is the concurrency or parallelism we say? Concurrency is something like suppose if in case if more than one user he want to edit or he want to work in the file, right? It cannot happen. Why? Because like at any one point of time only one file will be edited. It means that when a file was edited by a particular developer, what happened, right? The file used to get locked actually. Some kind of a lock mechanism was used, and after the lock mechanism was used, like for example ram want to edit some file, so what happened, right? He will go and he will get into the file, and automatically that file will get locked. The file will get locked actually. Suppose you're working on some file one. Okay, so some kind of a locking mechanism should have would have happened, sir. So some locking would have happened, so that what happened, right? This lock is to get assigned. So once the lock is assigned, it means that any other developer he cannot do any changes to this file. It means that he will not be able to get the permission to access this file at all. So he will get to know that oh, some particular other user is actually trying to edit this file. So he should wait until this lock is released. Once the lock is released, it means that this file is free. Now any other developer can access this file. So before he accesses it, he has to obtain a lock. Once his lock is obtained, then only he can edit the file. So that is what it was happening. It means that at any point of time, only one file was trying to get edited. You will not be able to, you are not able to do on a, you are not able to do any action or performance on the multiple files. So that was happened in case of a first generation actually. Okay, examples. If you see an examples or which are the tools which comes under this first generation, right? You could have not even heard about this. There was a tool by name as CSS, and there is some tool as a RCS actually. So this nowadays no longer used by any people or any company. But I'm just telling you, like this was a very old or the first generation of your version control tool. Okay. After that, you got something okay, second generation actually. In the second generation, sir, second generation is something you can even call it as a centralized version control system. Okay. In case of a centralized or in case of a second generation, what was our architecture basically? How it was working basically? Here, what happened, right? We used to have one server. So let me take some server icons. Okay. Yeah, this is a server icon. So they used to have some server, guys. We used to have some server. So this is a server, okay. And here in this server, we used to install some versioning software. We call it as a versioning code software, VCS software, which we were installing in this server. Okay, it is like a versioning software, guys. Okay, this was a main centralized server. Okay, and this we call the VCS server, we used to say, and we used to have many of the other client machine or many of the other user machines, right? For example, if I say I'll take this. So this is one client or one user. So like this, like this. So here what happened that you used to have a multiple client. Here in each and every machine, guys, what happened, some software is to get installed, and that is something like a VCS client software was installed in each and every user machine actually. So consider that these are the three developers who are working on a project. Okay, each and every developer have their own laptop, right? So in their laptop, this VCS client software was getting installed. Right, and you could see that actually you used to even have a kind of a one more backup of or recovery server, right, where like we can have one more server, right? So you can have one more server like that. This is kind of a backup or a recovery. It means that whatever the data which was there in this server, right, this has act like a primary server and this act like a secondary server. So there was basically a sync between both these servers. It means that whatever data it used to get stored, no, the same data will get synced and it gets stored over here also. It's like a secondary. Similarly, if this server, the primary needs any data, right? So those data also it could have been retrieved back from the secondary server like this. Now, what happened in case of a case of a second generation actually basically. So I'll just write it down the what was the networking over here. The networking over here is that earlier there was no networking in case of a first generation. Here the networking is that actually it was a centralized network actually, because we have a centralized server here. Guys, we have a centralized server over here, right? We have a centralized server here. This we call as a centralized server, correct? We call it as a centralized, or we can call it as a centralized version control servers. So this is a centralized version. Now, so here what happened, right? What and okay, let me complete this writing the notes first. So networking was centralized, okay. What was operations you can do it over here? So here the operations is that actually you can work on multiple files. Okay. What was a concurrency? Concurrency means parallelly. What was a parallel activity which you can do? Concurrency. Here, parallel activity means that you cannot edit more than one file. It means that there is some kind of a locking mechanism was used in case of centralized. Sorry, in case of a first generation. In second generation, what happened? The concurrency is that actually like you have to do merge before commit. So guys, don't worry about this. What is this terminology is merge before commit? We will be learning all these things in our upcoming sessions. So it means that before he commits, he has to merge the code and then finally he has to commit it. That's what we say. So, and what are the examples actually? What are the tools or what are the examples or the tools which comes under second generation? This list is huge actually. Like we have a CVS tool. Some of you might have heard about it. You have something like a source safe and subversioning tool. I have used the subversioning tool in my previous organization. Subversioning tool. Some of you have heard about the clear case, guys. IBM clear case, very popular tool during uh, long back, right? And what else? Somebody might have heard about the Team Foundation server. So these are some of the examples of the source code versioning tool, which were the second generations. Actually, it was centralized version actually. Now here, what happened, no, guys? Here, what happened, right? These are the client machines or the developers. So what they used to do, right? They used to write the code over here, correct? They used to write in their machine code, correct? Each and every developer is to write the code over here actually. Once they write the code here, what they used to do, right? They used to submit that code into this machine. But in case of a centralized machine, what happened, right? This server should always be up and running. It means that the client basically he will try to connect to the server, and then he will be trying to write the code changes actually. Basically, the whole software code, right? It was there in this server itself actually, right? So whenever any client or any user he want to edit any file, he has to log into this server, okay, and then do the editing of the files actually. So it means that it should always be online editing. It means that here the server should always be up and running. Guys, correct guys, right? It is centralized. It act like a basically like a client and the server model, where the client has to connect to the server and then he will try to do the changes into the file, right? So what is happening is that actually, so he is to write the code and he is to submit the code. It means that he is to submit the code means he is to push the code, or he is to edit and he is to save that code over here. Similarly, this customer, this client also does the same stuff. He is to, sorry, he is to write the code, is to get connected to the server and write the code and do the changes in the code itself, or the commit the changes. Similarly, even this client also does the same stuff actually. But here what happened, right? In case of a client server model, you could see that multiple users are allowed to do the changes to the same file or to the different file, or to the same one file, or to the one or two files, or same file with first line of code or second line of code. They can do change. Even they can even work or do the changes in 100 files also, different files. So it was possible in case of a client and a server no, model, right, where you can do change, multiple users can do an editing to the multiple files actually. But here the point here is that actually, like, now suppose assume that this user, okay, this user, the first user, he is trying to do changes to the same file actually. Okay, some file is there, something like some file one is there, some file is there by name something like file one. So he is editing, this user, the first user is editing to the same file, and even the second user is also editing to the same file. Assume that this person has edited the same file and submit the changes actually. It could be onto the same line or it could be onto the different line. Maybe assume that on the same line of code, suppose this user is editing from the fourth line of the code. He's editing on the fourth line of the code. Guys, okay. Even the second user also, he is also trying to edit onto the same line of code. Now the point here is that actually when this person he completes his changes, he will try to submit these changes, or he try to submit the changes into the main server, right? At the same point of time, even the client to, or the second user also is trying to submit his changes. Now at the same point of time, if both are submitting, this server will allow only one person to do it will take the request from only one person. It will not allow the second person to do the code change because it has to wait. It is something like, for example, if there are three people, if both all the three people they want to book the same book bus ticket, can they choose the same seat at the same point of time? No, right? It means that the software will always allow only one. It means that software or the server will always allow only one user to grab that seat from that bus, right? From that particular bus, right? Whoever is booking the bus ticket, right? So it means that it could be 100 people who might be booking the ticket, but what happened at any point of time, it will allow only one request at a time. It means that it will only one serve. Otherwise, if all the three users who are booking the ticket, no, if all are booking and the server is allowing you to book the ticket, everyone will get the same seat ticket they'll get, right? So that should not be the case, right? So here also in this case, if what is happening that this user he's committing the changes, he commit the changes to the server. While committing, it will make sure that any other user should not commit onto the same file. So that is what the VCA server will do. It will not allow to do the changes same file. So what is happening that he will submit the code changes, and then he will just disconnect from the connection from the server. Now, whenever the client two, or this so not client two, the second user, no, he is trying to do the same commit of the same file. Before he does this, actually, he has to pull the latest changes. It means that whenever he's doing the commit, before he do the commit, he has to check whether there is any updates onto this file. So he might not be knowing, right? See, these are the three developers. Who will know what are the changes which has been done by the file? Nobody knows, right? So this user, He might be editing the same file 1 from the fourth line of code. Even this user also might be doing this line code change from the fourth line of the code, right? Even this user also might be editing the same file into some other line of code. We don't know. Each and every developer, they might be working onto the same file or onto the different file or onto the same line of code on the same file. We never knows, and they're not bothered to ask each other whether in which line of code you are editing, right? Because these three developers are separately working but onto the same project. But what is happening that whenever you are doing a code commit or whenever you are trying to push your code, before you push the code in your server, you need to check whether there is any updated code or updated file is already there. So that when you're pulling the updated code, then this user will get to know, oh, okay, already this file has been changed by some user. Oh, he has edited on the same file. Okay, let me push my code below this line of code, whatever this user has did, so that this person get an idea actually. So that's the reason I'm saying that what is the concurrency means, before you are committing, your code has to be merged with some other code also. It means that this person, before you are committing the code, he has already committed. So first you need to get the latest code changes from the server, and then check it out whether he has edited into the same file line or a different line, whatever might be. Appropriately you fix or you reposition your lines of code into the file, and then you commit it. So it means that commit will always happen onto a same file at only one point of time. But multiple users can actually work onto the same file. See, this user is also working on the file 1, this user is also working on file 1, and this user also can be working on the file 1. But whereas in the first generation, it was not possible. It means that only one person can work at a time. No two users can work at the same time because there is something like a locking mechanism was there. So this was somewhat little advantage when it comes to the second generation compared to the first generation, right? Because you are trying to do work onto the same file. So that was possible, right? But here, one big problem is that actually always that this server should always be up and running, guys. Sorry, this server should always be up and running. If this server is down, no, then this client or this users, no, they cannot submit their code. So there is something like this is a perfect example of the server and client model or the client and server model. We say a TCP client and server model, right? Like that model. Okay. So this versioning tool, right? Whatever I have mentioned, right? CVS, source safe, subversion clear. These were using this client and server model, where always this server should always be up and running, right? And you know that if this server crashes, this server crash, suppose assume that you're maintaining only one server, you don't have any backup server like this, right? If the server goes down completely, it goes down or it crashes, so then all these people, they have to wait for their submission code because the server itself is down, they cannot do any changes to the file. So it means that there is no possibility of doing a offline editing, it is always a online editing. It means that the server should always be up and running. Online editing is possible. But later what happened, right? Some of the other tool like subversioning, right? Tools are there where you need not to have the server up and running. You can do the code changes into your system, guys. In case of some other tools, right? In subversioning, right? You can do the code changes into your locally. You can do, okay. Whenever you want to submit the code, at that time you do a connection to the server. So this user one, right? This is user one, this is user two, and user three. They would be editing their code, everything offlinely into their own system actually. Later, whenever they want to submit their code, at that point of time only they were doing a connection to the server and submit their code changes. So some tools like subversioning was supporting the offline editing also. But some other tools like CVS, how it always happens, like CVS always what happened, right? You need to connect to the server and then do the code changes and submit it, right? So hence what is happening that because of this issue, right? This issue of the server, it might goes down or there might be some kind of a maintenance activity goes on. That's the reason what happened that you'll always maintain a secondary server where all the data, whatever is there in this first server, right? There has to replica or the duplicate copy of this data would to be there into the secondary server also, or into the secondary server. This is a primary server and this is a secondary server. Correct, guys? And you know very well that always in this case, right? you need to maintain, like an engineer. Actually, you have to maintain an engineer who will always manages the server. So you'll always check whether the server is up and running, whether the disk is not full, okay, whether there's not much load into the server, okay, how the data are getting saved over here, how I can actually make a replica of this data from one server to other servers, right? And how I can make how I can make sure that there should be some kind of a load balancing happening. Suppose assume that hundreds and thousands of developers are submitting the code. This single server cannot take that much load actually. So in that case, what happens? There has to be some kind of a clustered, or there should be some kind of a distribution should happen, the load distribution. That also is been managed or taken care by the engineer. So it means that you need to hire some source code administrator who will manage all this activity. So earlier what happened, right? If you guys remember, you know that there was a huge demand for the clear case administrator earlier. I'm talking about some 10 years backstory. So even for the team foundation server also, the lot requirement was there where they were some people they can manage all this activity. It means that he has to be an administrator basically. Right, guys. So here this was a kind of a disadvantage in the centralized server where the server goes down means all the user has to wait until and until the server comes up actually. Okay. So this was a second generation, sir, actually. So here also you have seen some disadvantage, but it is better than the first generation, right? Little better than the first generation because multiple users can use it, multiple files can be written, and it is a centralized server actually. It means that all the users they have to connect to the same server to do their commit to their code changes. Correct, guys? Now, so that's what. What about the third generation? So which is very important. So here our interest lies, right, about the third generation. Third generation is nothing but it is a distributed version control system. It's a distributed one control system. Before I explain it, let me write down the notes actually what exactly it is. So in case of when it comes to networking, the networking is distributed. Network is distributed, fine. What about the operations? You can do operations like multiple files you can do, but we can call it as a operations as a change sets actually. Okay, and the concurrency or parallelism we say. What about the concurrency? Concurrency is something like here commit before merge. Here you could see that merge before commit, ulta opposite, commit before merge in case of a third generation. What are the examples of the third generation versioning tool which comes in the picture? You have one tool as a Mercurial. Okay, that is a third generation, which is a distribution version control system, and we have a Git actually. So Git comes under your versioning. Sorry, under the distribution version control system. Okay, so this is what it is very popular, and nowadays, as you know, most of you know that we are using the third generation source code versioning tool, that is Git actually. Of course, there are many other tools, but these are the famous tools actually, Mercurial and Git. So what this distributed version control says, what is it all about? So he says that actually in the distributed control system, right? Basically, we have a servers or we have a nodes actually. So what we say, we have a source, we have a servers or we have a nodes actually. So I will take server icon. Where is that, sir? We have servers like this, sir, actually, right? We used to have a server like this. Or you can write like this, and like this, something like this. We used to have a servers. We call this as a nodes, guys. We call all these machines or as a nodes actually. This is a distributed system. This we call as a nodes actually. All these machines are nodes actually. So this we call it as a distributed version control system. Okay. And here you have something like a networking, right? All these four machines, they were able to connect each other with the help of a networking. It could be an extranet or intranet, anything. One second, guys. I'm getting a call again. Okay, fine. So all these machines, they were interconnected with this networking, actually, like this. Now, this is the distribution version control system. In case of distribution, what they say, but basically that every node has to have a same set or same copy of the code, actually. Means the complete set of the copy of the code is used to have in the same server. Copy of the code of the same of the code used to be or used to be present in every node, actually, in case of distributed network, in case of distributed versioning system, in case of a distributed systems, actually. So what it says that actually basically, suppose you have in one machine, you have your entire source code, whatever you have written, right? The same copy of the code used to have in each and every node when it comes to distribution. Whereas here, in case of a client and the server, you know that only server used to have the complete code, sir, complete source code, right? Whereas each and every other user or the client or the developers, they never used to have the complete code in their system. They has to have only part of the code or part of the file which they were working. But in this main server, it was meant in the complete code here, right? So whatever the file change sets which changes which they were doing, only those file changes they were committing to the server, and the server is to accept the changes and it is to give some kind of versioning for that, right? In case of a server and client, you understand that the entire source code was there with only server, not with the clients, actually. But here, what happened in case of third generation or distributed system? Okay, here, see here what happened, right? In case of second generations, you know that there is something like a client as a server, and always the client has to get connected to server for doing any kind of a code changes, right? There is a client and server model is acting over here. Whereas over here, in case of distribution, there's nothing like a client and server. So everything are nodes only, or everything is are the main server, and every server has a complete copy of the same code in each and every server. If I am having, oh, I'm having. Suppose assume that tomorrow, if one more server comes into the picture in case of distribution, one more server comes. One more server comes, sir. It says that even it comes under the distribution. Even this server will also automatically get the complete set of code. Some people might say, Rajesh, in that case, what happened? Like the storage will be huge, right? Why we are having a multiple same copy of the data in each and every server? Doesn't it affect the storage? Sir, you know that nowadays the cheapest thing, in a hardware is the storage only. So storage is not a big matter over here. The consistency of the data, right, or the replicas of the data are more important these days, right? Storage is not at all, storage is not at all a challenging task or the difficult things to achieve. It is very easy because it is very cheap and it is very easy to affordable. So that's what in the distributed we say that we are having a same copy. Why we are doing like that? Because of some reason this server get crashed, and even this server get crashed. Even this server get crashed. Assume that out of these four, three servers are crashed. Still you have one server, sir, where you are having a data, right? Still you can recover your data, right? So it means that the redundancy of the data is there, actually. Here in this case, what happened, right? Here what happened, right? The redundancy data is there unless and until you don't you are not you are making up the backup of this data into some other secondary server. The redundancy of the data is there. But assume that this only one server is there where you are maintaining the complete data. Means the whole project is running. It means that tomorrow you want whatever the developers are developing, they're pushing the code, right? From here itself, the code should be pushed to the production. It means that So whatever the code is there, that code has to be get compiled. Okay, the build has to be done, and the same code should be pushed to the server, to your production server. It should be pushed to the production server, and this is a production server. Assume that. So under that case, what will happen if there's only one server? If the server fails, if there's a disk crash happens, what happens? You are losing the complete data, right? So no build activity, you cannot push any code to the server. It is gone case. Very difficult to recover back your server again. But of course, I mean, in that case also, people will maintain different they will maintain a cluster of server where they'll have the same copy over in the other secondary servers also. But I'm just telling you one scenario where assume that there's only one server is there. So if the server crashes or if the disk crashes, you are losing the complete data. Whereas here, in case of distribution, there is nothing like that. You are having multiple nodes. It's not only 4, there are having hundreds of nodes. Each and every node will have the same source code or same code set. So in that case, what happened? You are maintaining a high redundancy of the data. The data will never be lost actually. And it is a very simple approach also to have a distribution version system actually. So that's how this design came into the picture. Why exactly distribute came into the picture? Because to maintain the same copy across the different machines or the nodes, that was one of the reason. And to make it very simple way of using or managing the source code, right? It is also possible with the help of a versioning control system. That's what the design was laid out to come up with this distribution version. So, but guys, this is a very high level I'm telling about the versioning system actually. Right now, what happened? Right, we'll come to the actual thing. How exactly the distribution version system control works basically. Right. So, what happens basically? Right, you have a server over here. Same thing. So you have a server over here, right? And here you have a clients or you have a users actually. This is I'm talking about the distributed system itself. In case of distribution, right? In this. So now, so this is nothing but this is a server, sir. Okay, this is a server. Again, it's the same thing, sir. What this is the distributed distribution version control system, DVS, distribution version control system, sir. Okay, now this is a server actually. This server has the code, the complete code, source code. It has the same source code. Even it used to even have the client server side also. It means that even with the user, each and every user, this consider this as a user itself or is a developer. Even he too also having the same complete course code actually, the complete code actually. So here there is nothing like a client and server, sir. Everything has nodes or everything we call as a server because everything it has every machine or every user has the same set of code. But you are differentiating something with this machine or with this main machine because this is a server and this server you are installing some extra software, sir. Some kind of extra software you are installing actually to make it as a server actually. That extra software it provides some kind of a services. What are the services it provides? It provides the services like services for connectivity. Okay, it means that if this machine or this client or this user he want to connect to this machine or connect to the server, how you can connect? Because there is some software which enables it provides the services where it provides the connectivity. Okay, what are the other things? User management. It means that you have a code actually, sir. So you can create some user accounts in this machine like Rajesh, Mahesh, Suresh, and you can tell that okay, this Rajesh is having a full access to this code. Okay, the Mahesh is having access to the code, but he don't have a right permission to certain files. Some kind of a user management, some kind of a permission providing. You provide the permission to set of files or to set of folders and all, right? For that reason you need to have some kind of a user management actually. So that also is provided by that some software actually. So but in the code wise everything is same, correct? This machine, even this machine has the complete code. So code wise, sir, there is no difference because even every machine will act like a node itself. But this particular machine we are calling specifically it as a server. Why? Because that we are installing some software. What is that? We will see later. And that software will provide the services. What a service it provides? It provides a service of connectivity. What connectivity means that it allows the user to log into this machine and do the code change or code commit, and then you can even provide some kind of a user permission. It means that this particular user, he has some particular permission to be provided into that particular, like into the particular repository, into that particular folder. So some kind of user management is enabled with that, with the help of this extra software, so that this will act like a server. That's all. So this is in case of distribution system. Every machine is a node only, because you have to say that every machine has the same codes, the same set of code, no difference. Tomorrow, assume that actually tomorrow you are trying to bring one more machine, right? One more machine. You're trying to bring one more machine. Even this machine will also have the same code, sir. Actually, the complete code it has. So now you could see that there are multiple same copy of the same software you are having in a multiple machine, which also act like a nodes. So the distribution, we first say that these are all the nodes because it has the same source code, right? Same set of code here. So if the one machine goes down, if this machine goes down, or if this goes down, doesn't matter. It doesn't mean that you are losing the data, because this data is a replica. It is there in many other machines. This is what the advantage in case of a distribution version control system, guys. Okay, so what we are going to learn, and the Git is which tool comes under distribution version control system. We said that the Git is a tool. Actually, Git is a version control which comes into the distribution version control system. Okay, guys. So what we are going to do, guys, in the next class, we will go ahead further, and we will try to see like how Git will be used in case of a distribution version control system. How Git plays a very major role in maintaining the source code, everything, and because it is very easy to maintain. That's what I said. It's very easy to maintain, and no, Git is free. There's no licensing cost, right? That's what I said in the notes. Right here, you could see that it's simple to use, and it's a platform independent. It means that if suppose if your machine is a Windows machine, here also you can install Git, and this is a Linux machine. This is the Mac machine, and this is a different flavor of Linux machine, right? Everywhere you can install Git actually. That is what the advantage of having a Git. Okay, now to give you some background about the Git, sir, like you know very well that like Linux, basically the Linux operating system, right? The Linux operating system OS was designed, or the operating system, or you can call it as a kernel, was basically designed by Linus Torvalds. Actually, he's a guy who designed the Linus Torvalds, or Linus Benedict Torvalds. He's a guy who designed this. Actually, the same guy, he wanted to write a tool actually where it supports a distribution system. Actually, it means that he want to write a piece of software or the code or the tool where it supports for the distribution version control system. So that's the reason what happened, right? In the year 2005, Linus Torvalds came up with this Git tool actually. Okay, and he pushed all his Linux kernel code to be maintained under the Git itself. Actually, that's what he did. The whole Linux source code is maintained through the Git only. That's a big reason it becomes very popular, because the Git source code itself, sorry, the Linux source code itself was maintained by the Git itself, and because Linux source code is not small, it's a huge project actually. So if that such complex project is being used, right? Obviously, what happened, people were interested to learn about more about the Git actually, and finally, what happened, like many of the companies, they started working on Git heavily. Okay, so if you want to see it, right, you can see that he's a guy. He's still there. He is around 48-year-old, not 48, around 50s. Is Linus Torvalds. He's a guy actually who has designed the Linux kernel, as well as he's a guy who has developed this Git software also, or Git tool. Okay, guys. So that's all about today. And what we are going to learn tomorrow is that we will be learning about the architecture. Yeah, of course. One more thing I want to tell you, that the installation, right? The installation, Git installation. So as I said, Git can be installed anywhere, right? When it comes to the Windows, sir, Windows you need to install the Git software. Okay, you can just go to the Google and just say that Git download. So you could see that you can go, you can download your Git here. See, because it is a Windows, right? You can nicely download it. Once you download it, once you install it, if you say click, 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 next, 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 it get installed. It get this Windows, sorry, get this Git installed in your Windows machine. So once you install in a Windows machine, you could see that after, once you install, when you do a right click on it, here you will get as a Git bash here or Git GUI. If you click on the Git bash here, it will open you a prompt or terminal will open where it will like a Linux only, Linux prompt only, but it is a Git bash. Okay, here you can execute any kind of a Linux command here. Like I can execute ls command, I can execute the date command, I can execute who command, I can go to anywhere. So this is basically you will get kind of a Linux terminal or the shell terminal. So you better get installed your Git under your Windows also if you want to practice. So you can either download the Git and install it. Okay, or else some of you know that actually I don't want to do this. I want to directly install it. So there is something like a chocolate is there. Chocolate is there. First, you have to install the Chocolatey software in your Windows. With the help of a Chocolatey software, you can install any kind of a package actually. Okay, any kind of a package. So that you call also you can down. You can just go to the Google and you can just say that Chocolatey installation. Chocolatey. So if you go to the Chocolatey installation, you know very well that you can open your PowerShell. Guys, you can open your PowerShell. Like you can open a PowerShell, open with your administrator. I cannot do that because I don't have an access. Once you open it, actually, you want to install the Git. Sorry, you want to install the Chocolatey software. So you could see that, you could see that this is what the command is there. You can just copy it like this, and you can execute this command and say enter. I don't have a permission, so I will not be able to run this command. But in your system, you can able to run this command. So once you run it, Chocolatey will be installed. Once the Chocolatey installed, what you have to do is that choco install git like this you have to do. So you will get a command line in Windows, right? So if you go here, now you could see that actually see there is some command is there actually. So you could see that choco install git. Simply copy this command and execute in your this one in your PowerShell. If you install like this, run like this, choco install git. Whatever the command here are, right? Just copy paste on it. It will try to install the it will try to install the git actually. So this is easy way of managing your Windows machine rather than going downloading the software and do a double click on it, right? So that will be a painstake. So this is a easier way of maintaining everything in with your command line in your PowerShell. So this is the best way to manage in case of Windows if you are working on Windows. Similarly, if you're working on Linux, actually, Linux if you're working, sorry, if you're working on Linux machine, under the Linux machine, you can have a different flavors for your Red Hat or for your CentOS or for your Amazon Linux. If you're working on a Amazon AWS, Amazon Linux, right? You can install by the help of a yum install. Just say git -y this command. Or if you're using a Linux with your Debian, or we can call it as a Ubuntu machine, Debian distribution or Ubuntu distribution. There you know very well that I have to install with the sudo apt get install git software. So we can work on this Git anywhere, but what I'll be doing in my upcoming sessions, like I'll be using installing Git in the CentOS or in Amazon Linux. So I'll be working everything in your AWS, as you know. So in that AWS, I'll be installing the Git. So I'll be basically running this command actually, executing this command. Yum install, or else I might even use Ubuntu also. I will see who I will do, but I will be showcasing all our the complete Git explanation, everything with examples in CentOS or in Amazon Linux. Okay, guys. So this you have to know, guys. You have to install it. So you get your system ready. It is a simple, right? You have to go and you have to launch one instance in your in your AWS account, and then you choose whichever flavor you need, Linux, Red Hat, or CentOS or Amazon Linux. In that machine, right? Once you launch it, right, there you can run this command actually. So in the next classes, we will be seeing like how to install it, and finally we will be even trying to understand the Git or the GitHub overflow. So what is a day to agenda? Day to agenda is nothing but Git overview and the flow, like how the Git works actually. Plus, we will be starting across. We'll be understanding about the repositories. What are the repositories we call? Repositories means centralized repository or local repository. What is local repository? Centralized repository. Like that, we will be trying to understand these concepts. Okay, and we will be starting with the Git commands, basic commands. So that would be our topic for tomorrow. Okay, guys. So that's all for the day today, and I hope that you guys have understood, right? So if you have any doubts, let me know, or else we'll wind up the session. So it was a very small introduction, guys. So just to explain you about like how the distribution came into the picture, right? How the source code versioning came into the picture, and what was the disadvantage which was there earlier when it comes to source code management. How basically the developer is to exchange their code between them, because there was something like a shared folder, which was a very simple approach, but it has a lot of disadvantages, right? To overcome that disadvantage, right, what happened, right, we came across with some kind of versioning, that each and every code which has been pushed to some server, there has to be some kind of versioning or history has to be maintained, right? So to maintain everything, what happened, some people have developed some code of the software actually. So after installing it, actually what happened, right, your code comes under the versioning. So where for each and every code push or the code change or the code commit, some versioning or revision or some commit IDs to get provided for each and every code changes. So that's what that software was being able to do it, as well as it is to maintain all the history of all the changes. Later what happened, right, that first version, second version, generation, third version, all this came into the picture, and today we are under the third generation where we are effectively using Git as our source code versioning tool. That's what. And we saw what is a Git installation and everything. Just in a very high level, we try to understand it. That's all it is. Okay. So hope you guys, you hope you understood. Hmm? So okay, somebody can stop it if there's no doubts.